Good morning, everyone. Welcome to Bigtable, a journey from binary to service. I'm Gaurav. This is Brendan. We are both SREs at Google. Between the two of us, we've worked on Bigtable for more than 13 years. I'm the current Bigtable SRE-TL. Brendan was the Bigtable SRE-TL for 4 years. More recently, he's been working on cloud CI/CD and monitoring tools. So here's the agenda. In this talk, first we'll quickly go over what is Bigtable. Then we'll talk about why we needed to build a Bigtable service at Google. We will also talk about how Bigtable service evolved over time. And finally, we will go over some of the lessons that we learned while building this service. To start off, what is a Bigtable? Bigtable is a distributed storage system for managing structured data. If you're familiar with HBase, HBase was developed based on the description of Bigtable that was published back in 2006. It's essentially a distributed system that's been around for a while. You can think of it like a giant database. So Bigtable at Google has been in production for over a decade. Any given table can scale to trillions of rows. Also, any single table can scale to petabytes of data. So in short, Bigtable is this distributed system that scales really, really well and has been around for a long time. At Google, a wide variety of products use Bigtable, more than 60 projects internally. It's a core piece of our internal storage offering, and it's also available externally as Cloud Bigtable. We are not going to talk about Cloud Bigtable today, but it's still out there, and anybody can use it. So this is what a Bigtable looks like from a user's point of view. A bunch of words. It's a multi-dimensional, distributed, sparse, sorted map. You can think of it as basically a table with rows and columns, but with an extra timestamp dimension. So each cell in the table can have multiple values. Rows are stored in lexical order, which means you can scan by a prefix, or scan from a start range to an end range. It's also sparse, meaning that gaps in either rows or columns don't take up a lot of space. You can have some rows that contain a lot of data and some rows that contain very little data, and this is all very efficient to store. Inside a particular Bigtable cluster, operations are atomic at the row level. Bigtable also supports replication, and this replication is eventually consistent. So this is what a Bigtable cluster looks like. Inside the lighter shaded section, we have two binaries, what we call the Bigtable master and the tablet servers.
You're losing the mic when you rotate your head.
Thanks. Clients only talk to the tablet servers. So all the data, all the reads, all the writes go through the tablet servers. Bigtable master is not directly in the serving path. It is only responsible for coordinating the work of the tablet servers. Which tablet server is holding what piece of data, checking if the tablet servers are healthy, checking if we need to load balance across the servers, and things like that. Tablet servers store their data in a distributed file system called Colossus, and they use a distributed lock service called Chubby for their system membership protocol. Chubby is similar to Zookeeper from the open source world, if you're familiar with that. So that's more or less what Bigtable is and how it works. This was just to set some context. We'll talk about other things in the rest of the talk, but it could apply to any of the products that you're working on. So we've talked about what is a Bigtable. Now we'll look into why we needed to build a Bigtable service at Google. Here's the original deployment model from when Bigtable was first developed. The Bigtable dev team wrote a bunch of code, and they shipped two binaries, a tablet server binary and a master binary. If you wanted to use Bigtable, you had to go set up your own Bigtable cluster. You had to figure out how to monitor your cluster. When your cluster broke, you would get alerts, assuming you set up those alerts. You had to figure out what was wrong and then go fix it. If the cluster did not perform the way you expected, you had to go tune it. So this works really well if you have one team or a small number of teams using Bigtable, and these teams can afford to become experts in Bigtable. When you start to have more people, when you have 5 teams, 10 teams, 50 teams, 100 teams using Bigtable, we quickly run into problems. As the number of teams using Bigtable increases, they all start to face similar problems. Which version of Bigtable do they use? Assuming you have new versions of Bigtable coming out regularly, and we try to keep up to date. Somebody has to make sure they are keeping track of the release notes, understand what features are in place, make sure they are updating at a reasonable time. How are they going to roll out this new version? Will all teams use the same approach or come up with their own processes? If they see a novel problem that they have not encountered before, how will they get help? Who will help them? How will they become experts at debugging Bigtable? Are individual Bigtable developers going to talk to them? How many people really need to know how Bigtable works? How are they going to monitor things? Will they know when things are not working? How will they respond to alerts? Very quickly, you find that teams across the company are dealing with the same set of problems. Everybody is reinventing the same wheel. This is inefficient and not the best use of anyone's time. So this is kind of what it looks like in practice. You can imagine that we have one data center, which might have an ads Bigtable cluster, a maps Bigtable cluster. And you may imagine that there are many more clusters as you have more Bigtable users in this cluster. And then you have this second data center. And this one might have a search cluster and another maps cluster. It also probably has many more Bigtable clusters. And you can imagine that there are way more than 2 data centers. You can see that this quickly leads to many, many Bigtable clusters and many teams having to manage copies of their Bigtable clusters spread all over the data centers. And this quickly leads to sad people, sad panda. So this is where the SREs come in. SREs generally don't like toil. SREs really don't like duplication of effort. And the SREs think that this is a problem that they can solve. A few SREs focused on managing Bigtable should probably be able to do a better job than a bunch of engineers spread all over the company spending a little bit of time on Bigtable. This should allow teams to focus on their core problems and not worry about running Bigtable. So why don't we build a service?
So Gaurav talked a little bit about what Bigtable is and why we needed a service. And now we're going to talk a little bit about how it is that we went about building the service. So at first we think, how hard can this really be? We know how to run a single Bigtable cluster. Everyone was already doing it already, we saw. And so this really can't be hard. We'll just deploy Bigtable in a for loop, and we'll run it in all the clusters that we need to, and everyone will be happy. This is probably not that hard. But it turns out we have a problem. How many servers should we actually run in every cluster? Should we run 50? 50 sounds like a good number to me. Maybe no one will ever need more than that. But the more I think about it, I think maybe we'll need to run 500 servers in one cluster and only 50 in another. So we can add a config file. And then we'll just change that config file as needed, and then we'll still keep our for loop, and that will go and push all the configs out to production. So this is what the config file might look like. You can see it says that there's 100 tablet servers, and this particular cluster is running version 47A. That seems pretty simple. And we can update this config file whenever we need to. So if we were to decide that we actually need 120 servers in this particular cluster, we can update the file, and then we can write some software to push this config to production. So now all we need to do is update the file and run this command right here. Then the config is pushed, and everything looks good. But turns out I don't really like editing config files by hand. I have to open them in an editor. I have to find the right line. I have to be sure not to fat finger the edit and do what I want. It's really hard to script. And after a while, SREs immediately find that this config file editing is toily, and they can write some software to do this job for them. So the first script that we write, you can imagine, is something like this. And it's called BT resize, and it will edit the config file for us. And then we'll push the file to production. We'll push the file to production using the same tool that we were using before. But it turns out this is also a pain, because writing software to edit config files is kind of hard. You often wind up stomping on changes that other people make. You often wind up stomping on things that you don't expect to be there. You add something to the file and the software doesn't know how to handle it. People push conflicting changes that produce merge conflicts. So maybe it would be better if we just had a single source of truth and a consistent database. So now instead of editing the file, we'll first run this command to change some information in the database. And then we'll run this other new command, which will take the current copy of the database and dump it out into a fresh new config file that overwrites everything that's currently there. And then we'll push it out to production using the same config, the same command we had before. So this is getting a lot better, but an SRE still needs to be involved. And I don't know about you all, but I really dislike manually pushing resize changes to production. So wouldn't it be easier if we actually made this self-service, and then customers could scale things up and down as they needed? So we built that, and this is more or less a simplified version of what this looks like. User can interact with an admin interface, they can use an API, they might use a CLI, they could use a UI. And they can say, I need to add servers in this particular cluster, and then the config will get updated, the updater will get notified, and this will get pushed out to production. And this story is more or less how the Bigtable resizes evolved over time. Initially, it was SREs updating config files, and today it's this automated self-service system. This is, of course, a greatly simplified version. But it turns out that there are other problems that we run into besides figuring out how many servers we need to run where. We also need to figure out how to share resources now that everybody's sharing clusters. We need to make sure everybody gets a fair share, and therefore we need a quota system. If somebody uses all the disk that we have, it's going to break the system for everyone. So we'll need to keep track of the bytes that everyone is using, and we'll need to come up with a way to enforce quota. This probably doesn't sound very hard. We'll just continuously keep track of disk, and then we'll just stop them from writing when they hit a limit. What could go wrong? But it turns out that any system that can block a user's ability to write is, it turns out, a huge source of outages. You need to be really confident that your quota config is valid. Maybe you can verify that the config is parsable before you push it. But you can also have a valid config that causes an outage. What if you push an empty config? What does that do? What if you push a config that has zero has a zero quota for every user? What if your most important user makes a mistake and accidentally reduces their quota? Your software is running fine and doing the right thing, but the important user made a mistake. Do you really want to block their ability to write? What if your quota system has a rollback and returns old data? What if it's unavailable? So we had to add a few more components to the system to take care of all these problems and more. And now we've solved our quota problem, we solved our resize problem, but now we need to deal with all the customers that we have. All the customers that were running their own Bigtable clusters before had to deal with their own performance problems, but now they're going to come to us. And they're going to come to us and say the Bigtable is running slow. And we're going to say, well, how fast do you expect it to be? Maybe there should be an SLO. Maybe a single replica and their replica set is slow. Maybe it's a problem with the network. Maybe there's a single bad machine somewhere. What could have changed to make it slow? Maybe we released a new version of Bigtable. Maybe there was a kernel upgrade under the covers. Maybe there was a problem on a network fiber somewhere. So it turns out this is quite complicated, and everyone's going to be looking at us now that we're running the service to solve these problems. And so we're going to need to make sure we have good instrumentation running on the service. And we're probably going to need to add a few more components to the system to make it easier to troubleshoot. And then at some point, somebody will come and say they need to turn up Bigtable on a new continent that we've never run on before. And we'll need to figure out, what does this mean for us? Well, we need to change our turnup automation. Do we even have turnup automation? If not, maybe we should write some. Is there support infrastructure that we need to run on this new continent? Do we know what it is? Do we know if it's running there? How do we make sure we turn up dependencies before we turn up ourselves? And so we need to figure out this problem. And then the company starts to grow, and the service starts to grow, and somebody eventually appears and says, hey, all those machines that you have, maybe you should pay for them. And then you say, wait a minute, we were just trying to make everyone's life easier by running Bigtable for them. We don't actually have any money to pay for all these machines. Like, how are we going to solve this problem? So then you need to add a few more components to the system to deal with this. And then somebody shows up and they say, hey, now that you're paying for the machines, it would really be nice if you told us in advance how many machines you actually need. Do you need, how many machines are you going to need 3 months from now? How many machines 6 months from now? How many machines a year from now? And I'm just thinking, I'm just running Bigtable on behalf of other people. I have no idea how much Bigtable they're going to need a year from now. So we need to add some components to deal with that. And so these are some of the problems that we encountered as we started to build the service. And we wound up having to solve these and probably quite a few others. And we wound up with a service a system that looks more or less like this. So this is an excellent rendering of what the Bigtable service looked like at one point in time. In fact, if you look in the upper left-hand corner, you can actually see this is from 2012. And remember that Bigtable cluster diagram that Gaurav shared earlier? It's here, everything in that is in this little cloud here in the center. That was this diagram here. So all of that actually inside that cloud. And then my favorite part of the diagram is in the lower left-hand corner. And then we can zoom in a little bit and see what that is. So here you can see that there are some SREs, that they're taking care of the system. They have a pager that's getting alerts that are coming off of it. And apparently these particular SREs also seem to be drinking a fair amount of coffee.
So we talked about why we needed a service, how we went about solving various problems that we encountered along the way. We've been running Bigtable Service for over a decade now. Here are some of the lessons that we learned during this time. So when we started, we thought we would just deploy Bigtable in a for loop so that people wouldn't have to do it themselves. We thought it would be simple. But we ended up building this incredibly complicated system that we did not originally set out to do. It wasn't really our goal to build another system. But as we solved various problems that came along the way, we realized that, in fact, we ended up with another distributed system. So now we wind up with these two distributed systems. On one hand, we have the Bigtable cluster comprising of master and tablet servers. This system allows users to read and write data, create tables, replicate their data. And then you have this inadvertently built system on the other side, which deals with turn up and turn down, resizes, data migration, monitoring, alerting, chargeback, and so on. And it turns out that it's mostly been the dev team that's been building the system on the left. And it's mostly the SRE team that's been building the system on the right. So this is quite interesting, and it got me thinking about a law called Conway's law. Perhaps some of you are already familiar with this. More or less, this can be summarized as you're destined to ship your org chart if you're not paying attention. We have two different teams, and they each build their own system to solve the problems that they care about. This isn't really great, because it turns out the customers only see one product. They just see this one giant box called Bigtable. They don't really know the difference between the core Bigtable containing the master and the tablet servers and the outer Bigtable service that deals with things like resizes and quota. So we have these three perspectives that we need to think about. Customers just see this black box called Bigtable. They don't care what's inside. They don't really care who built what portion of the system. The devs see the relatively constrained system that they wrote code for, which deals with a single cluster at a time. And then the SREs see this giant service with all the components and the various integration points and the glue between the components. Here's a somewhat sad story to illustrate the difference between the two systems. Imagine you're a Bigtable customer and you're trying to turn up in a new cluster. You're in a new data center. Maybe you've migrated from a different data center and you want to expand your capacity footprint. When you turn up your service in a new cluster, you have to do a couple of different things. You have to first get capacity in the Bigtable service, and then you have to write the data that you need to bootstrap your system in that cluster. So it turns out you need to use two completely different set of tools to do what is fundamentally one task in your view. You have one set of tools, maybe it's the UI, maybe it's the CLI, to get capacity in a cluster. And then you have this other set of tools to create your table and write your data into it. This is sort of weird from a customer point of view. They're just trying to turn up a Bigtable, but they're forced to deal with multiple tool sets for essentially doing the same thing. The first set of tools was written by the SRE team, and the second set of tools was written by the dev team. So the customer has to deal with extra complexity because we have these two systems. So how do we solve this problem? It turns out that we need to think a little bit like a product manager. We need to understand the customer requirements, and we need to work across the SRE team, the dev team, and build something that meets the customer requirements, but is also sustainable to operate. So here's one way you can think like a product manager. Let's say you have a customer.
I would like all my requests to be fast.
I could do that, but wait, How fast is fast?
Say 6 milliseconds.
OK. How about this SLO? Would 1 kilobyte reads at 6 milliseconds work for you?
That sounds great.
So I understand some of the customer requirements, but I still don't really know how many reads the customer will issue. Maybe 5 reads a second, 100 reads a second, 1,000 reads a second, 1,000,000 reads per second. Let's pretend I don't get this clarified with the customer. At this point, I go ahead and really over-provision the system to guarantee 6 millisecond read performance. I then go back to the customer. Here's your bill.
Wait a minute. I can't possibly afford to pay this. This is 20 times what my bill was before you gave me an SLO. I'm just not, how can I do this?
Well, you wanted your reads to always be fast, and this is how much that'll cost.
Well, hang on, wait a minute. What if you just make my reads fast when I've provisioned enough resources to pay for the work I want to do? How about that?
OK, that works. What about this SLO? 1 kilobyte reads at 6 milliseconds only when provisioning is correct.
That sounds good.
OK, so this is a relatively straightforward and obviously contrived example, but it's not too far from reality, and hopefully it gets the point across. You'll often need to think like a product manager. In practice, you may need to refine this SLO further. For example, in addition to capacity, maybe you also want to put constraints on the access pattern. Maybe you provide an SLO only when there is no hotspotting from the user. So other ways you can think like a product manager. You can meet regularly with your biggest customers. This isn't so bad. You might think I'm an SRE. Everything needs to be scalable. I can't really meet all my biggest customers. It turns out you'll always have top 3 customers, no matter how many users you have, no matter how big your service is. You could probably afford to meet with a fixed number, whether it's 3 or 1 or 5. It doesn't matter so much. You need to make sure that you understand how your users are using your service. What are their wish list items? What are their pain points? And so on. These customers will help to expose any scalability limits in your system. They will tell you when things are starting to break. It's really good if you can have a close relationship with at least one large user. You can make them canary some changes that you think will make a big difference. Your large customers will also present the biggest opportunities in terms of cost savings. You can work with them to find efficiency opportunities. Even small relative changes could turn out to be big numbers in the absolute sense.
So you start to think like a product manager, and you work with customers on shaping a single product. And now that you're thinking of it as one product, it's important to remember that you shouldn't limit yourself to changing just the service components we saw before. You're a software engineer. While you may have spent a lot of time working on the automation pieces that sit around the core system and the glue for all the integration points that previously felt bolted on the side, now that we're going for one system, you don't need to limit yourself to these components. You can go ahead and make changes to the core system that we showed before. So here's another sad but also true example. Imagine that a customer wants to know how much traffic each tablet, each range of their table is getting. Can we track and plot this over time? So it turns out that every tablet server has this status page, which shows details about the tablets that are loaded on it and how many QPS they're getting and what their size is. And so you think, great. I know Python, and I know there's this library in Python that can scrape HTML and parse it. So this sounds really simple. I should just be able to solve this problem in an afternoon by writing a script. But then it turns out that a new column gets added to the status page in the next release. And this new column is going to disrupt the clever HTML parsing that I thought I did when I solved the problem in the afternoon. So this is a simple example, but it's true. And it illustrates that the lack of a clear API between the service part of the system and the core part of the system resulted in problems, meaning that the tool that we wrote wasn't very maintainable. So there's a bunch of things that we could have done differently here. We could have added an endpoint to export the data in a structured way for scraping. Then we wouldn't have had this problem. We could have instrumented the load by tablet using existing monitoring infrastructure that we already had inside of the core part of the system. Then we wouldn't have had this problem. And there's a whole bunch of other solutions that you can probably imagine. But the point is, all of these only work if we were willing to go and make changes to the core system in order to make the tasks we have in the service easier. Even small changes are really important. Here's a message that used to appear in Bigtable. It says pass finished in 436,613,089. So what is this? Is this nanoseconds? Is it microseconds? Is it milliseconds? Is it days? Is it years? I have no idea. Is it even a duration? Who knows? So we recently improved this, and now it says this. Pass finished in 7 minutes and 16 seconds. Which of these do you prefer? I certainly prefer the second version. You can clearly understand what the units are. You know it's a duration. You inherently have a good understanding at a glance of how long 7 minutes and 16 seconds is. And depending on what pass this is talking about, you have a good sense intuitively as to whether or not 7 minutes and 16 seconds is a problem or not. This is a great example of small and simple changes that you can make to the code base that make it easy to troubleshoot and operate the system. Yet it took us years to make this change.
So remember, we have these two systems, one written mostly by the dev team and the other by the SRE team. As we worked on the service for a while, we started to realize that having two separate systems is a problem. We slowly started to blur the boundaries between the systems. SREs worked on the binaries written by devs, and devs worked on the tools and systems written by SREs. And the reason that this works is that we now have agreement on what we are doing. We understand that it is a single product. It is really important that everybody agrees to this. It won't happen overnight, but it is critical to get buy-in on the one product concept from everyone. So how do you get there? You need to build a strong relationship with your counterpart team. This involves a lot of communication that can sometimes take a lot of travel and a lot of discussions. Brendan has a short example.
So SREs had complained for a long time about a particular type of isolation failure. We had long and abstract discussions about scheduling strategies that could have been applied, and we had fights with the devs over whether or not the existing scheduling system worked or not. And we had these discussions for months and nothing really came out of it. Then one day I got a page for the issue. I grabbed the dev TL and I brought them over to my desk. And we sat down and we dug into the problem together. And as soon as they saw the problem in person happening in production, they immediately said, oh, this is what you meant. I have many ideas about how we could solve this. I can go back to my desk and start working on them right now. That was a huge change from the conversations that we had before. So having this discussion in person and showing them exactly what I was talking about was really important. The reason we hadn't made progress before was because I thought that they knew exactly what I was talking about and just didn't want to fix it. But it turned out they actually didn't understand what I was talking about. And once they understood and we were on the same page, things started to work the right way. So don't assume that people realize what you're talking about or know everything that you know.
Video conferencing is not a great substitute for FaceTime. Especially with distributed teams, you should definitely take the time to travel to the other side regularly. So now that you've agreed on the one product concept, and now that you're effectively communicating, something else you can do is share priorities and plan jointly. One particular anti-pattern is that SREs plan their work, devs plan their work separately, and at some point they share plans with each other. You need to understand what your common goals are. Don't stick to the mindset of, I'm an SRE, I'll just prioritize reliability, or I'm a dev, I'll just prioritize feature velocity. SREs need to be flexible when it comes to prioritizing a particular feature that a customer needs, even when they don't like the reliability trade-offs. Similarly, devs need to be flexible when it comes to dealing with production issues. Everyone drops feature work to help with the production issue if needed. Remember that the product roadmap will change as issues come up in production. So keeping in mind that you have one product, it's important to test that product and not just a piece of the product. It can be tempting for developers to just test the core pieces, but we have found that this is bad for a few reasons. For example, unless you test under the service, you will often wind up with a different configuration in your test harness versus that in production. And while testing at true production scale for something like Bigtable is really, really hard, it's important to make sure that you're at least considering multi-tenancy when building tests. For example, let's say you have a scheduler in your system, and this scheduler is meant for ensuring fairness between users. You really want to test this scheduler with multiple users? ideally somewhat close to the number of users that you might see in production. Testing it with only 1 or 2 test users may not really help to catch production issues. Something else that we've done in the Bigtable team is make sure that we share operational responsibilities across the dev and SRE teams. Just like the SRE team shouldn't shy away from making changes to the core system, the dev team should not abdicate entirely on production. This is really important because it gives the dev team clear visibility into the problems that Bigtable users are facing, and also a sense of how the code that they have written actually performs in production. Specifically, Bigtable developers handle nearly all the subcritical user communication. Questions like, how do I use this API? Why am I not getting expected performance here? And so on. We also have developers share the pager during business hours. It's really important to note that this is not a punishment, nor is it so that we can free up SRE time and we can do something else. We want devs to be on call for the same reasons that we want SREs to be on call. So they can see the system in production and understand what to fix and also how to prioritize these changes. When it comes to features, it is not just a dev responsibility. SREs should also be involved at design time. Having SREs in the loop leads to better designs, especially when it comes to things like isolation, resiliency, scalability, and observability. Imagine a hypothetical feature that is supposed to speed up the upgrade process for a cluster. SREs understand SLOs really well and should be involved to make sure that the feature is designed and tested in such a way that the system performance doesn't degrade and we don't burn error budget during the upgrade. We also find that having a customer involved early in the feature development process is extremely useful. Imagine a hypothetical feature that changes the way your backups work. We all know that a backup is useful only when you can actually restore it. So it's important that you have customers who can validate that the restore works for their application and workflows.
Skip this one.
Okay, I'll skip this.
So let's just quickly recap. A service is more complicated than just deploying multiple copies of a software. We thought that we'd make everyone's life easier by just running this for loop, but it turned out we built this whole system kind of by mistake. Try not to fall into this trap like we did and inadvertently build 2 systems that don't work well together. Try and design a product that's actually sustainable, that does something for your customers, that fits together, that's cohesive, and it's also sustainable for you to operate. We're all software engineers, and we should feel empowered to make changes to all parts of the system. Remember this message, 436,613,089 versus 7 minutes and 16 seconds? This was a really easy change to make, and it makes working with the system a lot easier. And finally, we found that it's really important for all of us to work together, devs and SREs, product managers, all the other functions, with the shared goal of customer and product success. Plan together, build features together, do operations together. You'll get a lot more done, and you'll have more fun doing it. And so on that note, everything we've learned about Bigtable and everything we've learned about how to build a system, run the service, wouldn't have been possible without a team of fantastic folks who've been willing to give each other the benefit of the doubt, focus on the customer, and learn from our mistakes. And we've been really very lucky to have a great team in our collective years at Bigtable. So thanks to all the past and present Bigtablers for taking the journey with us. And thank you all for coming and listening this morning. And with that, I'll be happy to take a few questions.
Is this mic on? Okay, great.
Hi.
Hey.
So for a new system, suppose it's something like or unlike a Bigtable, would you say it always makes sense to plan in advance to just run it as a service, go right ahead and run it as a service from the get-go? Or does it sometimes, based on some criteria, make sense to go with the model of, no, we just build it, you run it?
I think the pattern that we seem to have followed at Google, and probably the one that I think is the right one, is that if you're building a system as infrastructure and you intend it to be consumed by many teams, then building it as a service from the start is probably a good idea. If you're building something just for yourself, and you kind of think maybe one day it might be useful for other people, or maybe one day it might be a service, then perhaps trying to build it as a service from the start might be too much. But certainly if you know you're going to have multiple customers as an infrastructure service, then for sure you should build it as a service.
Another question? Anyone? Hans? Thank you.
So presumably, after 10 years, this is considered a stable or mature service in Google. So what does a tech lead do with a mature service in Google?
You might be surprised. so the scale is such that we don't have any low-hanging fruit, but the problems that we find are really, really hard. And these are the problems that have lingered. And there's always new set of features, changes that we need to make to the system, sometimes driven by customer requirements, sometimes driven by external requirements, like think of some laws or something. So yeah, and given the scale and complexity of Bigtable, these changes can take like many, many quarters. I'm happy to provide more detail offline.
Yeah, I really like the discussion about having SREs work with the devs on features and being able to pair on that. And it reminds me a bit of the XY problem, which is kind of used a lot in like tech support, where the question is asked, but somebody has come up with a solution that doesn't actually fix what they're wanting to do because they don't actually understand the problem they're asking. And is this similar? Have you explored like the XY problem in terms of when you're working on something that's a feature that you need from the developers? Like, is that something you've considered?
I'm trying to think, sorry. We have some sites where the dev and SRE teams are co-located. So if you have a problem, it's really easy to just walk over to the desk and say, hey, this is what I'm dealing with. This is what I need. Let's look at this together. And I don't think we run into that problem so much anymore. So I don't have a good answer for this.
Well, thank you so much. That was a fascinating talk, and I really think that Bigtable is probably further down the path of being a really mature sort of multi-tenant large service than probably anything else in the world that I know of. So that was fascinating. Thank you so much.
Thank you.
Thanks.